All right, so this first one's just a real quick review of, excuse me, a real quick review of what we were doing last week, okay? So as we look through this first one, a local politician wants to estimate a proportion, so, and then we have a sample where our p-hat would be 476. These are people who say they plan on voting for this candidate. And I'm finding this to be about 0.641. Everybody good so far? All right, so let's go ahead and start with kind of what our goal is to do and are we allowed to move forward with the question. So we're going to start with our procedure. As we talked about on Friday, right now you only know about one procedure, so you're going to do a one sample z interval for p. And p is always going to equal, I use the word true, you could say population, something that's like communicating that it's about everybody, okay? And not just about the sample itself, but rather generalizing to the population. That's what we're trying to estimate. So we're going to say the true proportion of voters of residents that plan on voting for the candidate. All right, now in order to run a one sample z interval for p, 3 conditions have to be met. Does anybody remember what those 3 conditions are?
Random, normal, and independent.
Random. It was hey, look it. We were given that this is a random sample. Normal. How do I check that normal condition? Do you guys remember? Well, we want to do NP, but we can't because we don't know P. The whole idea is we're estimating, so we use NP hat. Is everybody with me? So I'm going to do 743 times 0.641 and 743 times 0.359. We should get 476 and 267. So, well, what basically happens is this was rounded, right? So if I took this fraction times 743, I'm going to end up with the top number, right? That 470. You guys with me? So really, for NP hat and N1 minus P hat, it works out to be your number of successes and your number of failures. Does that make sense? And what are we looking for when we do these two numbers? What are we hoping they are? We're hoping they're greater than or equal to 10. What was the last one? Independent. How did we check that one? Your sample size has to be less than 10% of your population. In this case, that'll be residents in area, or who could potentially vote for this candidate. You can just assume. Okay? What are some other components? So we have our p-hat. So what are we going to do with our p-hat? We need to develop our margin of error. Okay. A reminder that you find that margin of error by doing z star times the standard error of the p-hats. Okay. What's my z star going to be? To find it, we can draw a picture. Z's have a mean of 0 and a standard deviation of 1. Okay. If we're 95% confident, we're talking about the middle 95% of the p-hats. Do you guys remember doing these now? And hopefully we're getting that z star is equal to 1.96. And our standard error would be the square root of 0.641 times 0.359 all over 743. I got 0.176. 0.0176. Which would be 0.018. We'll do it that way. So our interval is going to be the 0.641 plus or minus 1.96 times that 0.018. Is this feeling familiar? That doesn't feel right. But all right. I guess it's okay. And then that kind of specific version of the conclusion, we are 95% confident the interval from We feeling okay with this basic premise? All right, without doing tons of calculation, what would change if we wanted to be 90% confident instead of 95% confident? What part of my calculation would change? The margin of error in specific, because our margin of error is what? A z star and a standard error, yes? The standard error is based off of the sample size, yeah? Or is based off of what we got from the sample, and that's not going to change. So what happens is that Z star decreases. And I want to make sure we understand this because people tend to get these backwards. If your level of confidence goes down, your margin of error also goes down. Because if you're less confident, it's a narrower interval. Everybody good? Okay, so if Z star decreases, that means the margin of error is also going to decrease. Everybody good? All right. Look at this. The interval for this was 0.606 to 0.7676, right? The confidence level is the 95%. So if I ask you, so the margin of error when we do that smaller thing, we get is now would have been 1.645 times that standard error. So the margin of error changed, and it's because of that 1.645 is smaller than the 1.96. Okay. Now I want to talk about that interpreting the confidence level, because this is something that is very, very commonly not understood. So first of all, we have the confidence interval, and then we have the confidence level. Okay, so if we do interpret the confidence level, I'm asking, what does the 95% mean? What does it mean to be 95% confident? Now, do you guys remember last week, and I was showing you that where I would generate a sample, and I said, what's the probability that the actual value was in the interval? And we had one of two answers. It was either 0 or 1, right? For any one interval, okay? Because that 95% only attached when we had like all the greens and the reds and we were looking at it that way. We needed the large number of intervals for that 95% to make any sense. Does everybody, do you guys kind of get what I'm saying there? So we need lots of samples before the 95% makes any sense. Okay, so number one misinterpretation is what's the probability that this interval, that people will, and here's how it's going to happen. They're going to ask you this question in a multiple choice question, and then they're going to say that 95% means the probability that the interval contains P. But what is the probability that interval contains P? 0 or 1, but it's got to be one or the other, right? That one interval. That 95% only applies to lots of intervals. Is everybody good? So if I ask you to interpret that confidence level, you are going to say something along the lines of, if we took many samples of the same size, and created intervals from those samples. All right, so we can expect 95% of the intervals to contain the true proportion of, and I'm just going to do a ... because you want to do that in the context of the question. So it would be the true proportion of residents who plan to vote for this candidate. Okay. Okay, so let's skip that for now. I have another question later on that'll work. Okay, all right. Do you guys want the good news or the bad news? The bad news? We're going to do this again for this one. The good news, I'm going to show you the calculator shortcut for the calculations. Okay. And kind of talk through what the expectations would be. All right. So, very similar, except for now we have a different percentages, or a different sample. Okay? All right. So, we're still going to do a one sample Z interval for P. Okay. And we're going to go ahead and check our conditions again. We have random, but I believe we were given that this is a random sample. Normal. Let's go ahead and calculate our P hat. We get 619 over 1203. So before we get too much further into this, there's like kind of some big picture stuff. You guys, when you look at this sample, is the candidate going to win? Does the sample suggest that the candidate is going to win? Yes, because it's bigger than 50%. Yeah. However, what do we know about samples?
Samples are not perfect.
So could this be one of the samples that has a little bit higher proportion? It could be. Do we know that it is one way or the other? No. You guys with me? So the reason we do this whole stuff is because just because one sample said this, they could take another sample and it be 0.495. Do you guys see what I'm saying here? And that may or may not be crazy. And rather than trying to decide, is this big enough to convince us, we do the interval to make that decision. Everybody good? Okay. All right, so we're going to do 1203 times the 0.515 and 1203 times the 0.485. And we're going to get 619 and 495. And those are greater than or equal to 10. Independent, we're going to assume 1203 is less than 10% of the population. Okay. I'll do that for now. I think that works. Okay. So next idea is doing the calculations, and as promised, there is a calculator shortcut to doing this. Okay, so your rule of thumb is if you have to tell it to the calculator, you have to tell it to me. Is everybody with me so far? Okay, so what you're going to do is go ahead and hit stat. And we've never used this tests menu when we hit stat before, but you're going to choose tests. Okay, so go over to that. And you can notice that we have tons of stuff in here. Is everybody with me? All right. What we want to pick is if we go down and look at all of our options, do you guys see this one that says 1 prop z int? That is a z interval for a single proportion. That's the one we want to pick. Now, you are not going to communicate 1 prop z int to me by writing 1 prop z int. You've already communicated that by using the formal name. I don't want to see the calculator step. I want you to use the formal name as a 1 sample z interval for p. But that communicates that you've selected this one in the calculator. Everybody good? Okay. Go ahead and hit enter. We'll get to that one first. 1 prop z ints. All right, then it's asking for x and n. X is your number of successes. Will have to be a whole number. Okay, so that would be 619. N is 1203. Have I communicated these two numbers in my calculator? On my answer? Yeah, just by writing out what p hat is. Is everybody good? And we're doing 95% confidence. If not, you just put this whatever. It has to be a number smaller than 1 for your level of confidence. Okay? I go down and hit calculate. It gives me both the numerical value for p hat and it gives me an interval. Does everybody see the interval? If you accidentally hit enter twice, it'll delete and you have to go back and do it. Okay? So you literally just hit enter because it's not like one of the ones where it's like copy and then paste it. Does that make sense? But it'll save the stuff that's already in there. Okay? So if for some reason you go and do this and all of a sudden you hit enter twice because you've been trained to do that with some of the other menus in the calculator, just go back and do it again. That's all that's happening. Okay? And that is all the calculation I need to see. Okay? Now, that's all the calculation I need to see as long as you state this properly, the name of the procedure properly. Okay? So the way the rubrics read is that you picked the correct procedure by name or by formula. So if you don't want to write out the work for the formula, you have to write the name of those procedures precisely. Okay? Everybody good? All right. Let's go ahead and... Oh, no. I thought I hit record. All right. Next, we are 95% confident. The interval. couple of things. Your conclusions should rarely, if not never, be written in past tense, because you want to make sure your conclusions are written about the population and not the sample itself. Do you guys see what I'm saying there? And it's a huge faux pas that if you said contains the true proportion of people who voted for the candidate, that would imply it's already done. That also imply, like, we don't need to run an estimate for the true proportion who voted, because we know it at the end of the election. Do you guys see what I'm saying there? So you always want your conclusions to be in present or future tense. You didn't think we were going to talk about past, present, and future tenses. It's an English topic, and we're doing it in a math class. Yeah. What's up, Skylar?
When you write like the random, do you still need to write the random normal and things like that?
Always.
Okay.
So the shortcut is only for the calculation. Okay. Now, let's say it's a multiple choice question and you don't want to do the full thing. Do you see what I'm saying? Like, you still need to, also, you need to know the full format of it, even if you're using the shortcut. Like, you should know the components of that margin of error, because there's ways we can ask questions that don't include margin. You guys get what I'm saying? That aren't just the answer. Okay. So now, the big idea is we're trying to make an estimate, right? And why would the candidate care about estimating what % of people are going to vote for him? They want to know if they're going to win, right? So we also want to be able to use our interval to make a conclusion, okay? So if the election was held tomorrow, knowing this interval, can we say that the candidate is going to win?
Maybe.
Can we say that the candidate is going to lose? Maybe. Okay, what would this interval need to look like for us to be able to say that the candidate is going to win?
Like both parts of the interval are open.
So this interval is now representing all the possible results of what percent are going to vote for them with 95% confidence. So as we look at that, because part of the interval is below 50%, I can't say the candidate's going to win. And because part of the interval's above 50%, I can't say the candidate's going to lose either. Can I say the candidate is more likely to win than to lose?
Yes.
With 95% confidence.
We cannot say that the candidate is more likely to lose or more likely to win. You guys, remember, let's go back to this picture real quick.